Hello, my name is Tainara Michelotti. I'm a master's student at the South Dakota State University, and I'll be presenting about estimating dry matter intake of transition dairy cows through multiple on-cow accelerometer sensors. Beginning with a brief introduction, the transition period is one of the most susceptible periods of a dairy cow's life. During this period, there is an increase in nutrient requirements, first for fetal growth, then to lactogenesis. However, during the last weeks of gestation, cows often show a decrease in dry matter intake. During the week before calving, this decline can be up to 40% of intake. This change in dry matter intake is thought to be correlated with physical, behavioral, metabolic, and hormonal changes around calving. The decrease in dry matter intake is associated with postpartum health disorders depending on its severity and duration. Therefore, individual dry matter intake around calving is an important parameter that can be used as a monitoring system to flag cows at risk to develop a postpartum disease. In this scenario, we propose the use of accelerometers. Accelerometers are devices able to measure acceleration in the three axes, Z, X, and Y. They have been used in dairy research to estimate lying, rumination, and feeding behavior. Most studies have evaluated feeding behavior as a percentage of time the cows spend eating in 24 hours of the day. The prediction of the actual dry matter intake is a challenge. However, in 2019, Carpinelli and others were able to assess intake of lactating dairy cows using accelerometers. Data from our recent experiments have shown a greater variation in intake of transition cows when compared with lactating cows. In fact, we found a coefficient of variation of 13% for lactating cows compared to 32% for transition cows, which lead us to the question if sensor-based methods to determine intake can be used in transition dairy cows. Therefore, the objective of our trial was to evaluate the feasibility of using 3D accelerometer sensors to estimate individual intakes of multiple transition dairy cows. For materials and methods or experimental design, 18 multiple transition hosting cows were enrolled in our study. Animals were trained to use the Gate feeding system. From day -7 to +7 relative to calving, we collected accelerometers and dry matter intake data. Animals were fitted with 3 accelerometers in the jaw, nose, and rear left leg. Those devices were set to record every 60 seconds throughout the experiment. Data from the accelerometers was analyzed based on Ledgerwood study that validated the use of accelerometers for lying behavior in dairy cows. The G-force in the X, Y, and Z axis of each accelerometer are on a scale to -3.2 to +3.2. We then added 3.2 to all values to make them positive. According to Ledgerwood, when the leg G-force in the y-axis is greater than 2.55, means the cow is lying. Those time points where the cows were lying were excluded from our data because they represent a great period of time during the day, but they are not correlated with intake. Cows were then assigned into 2 groups, a calibration and a validation group. In the calibration group, we first evaluated the acceleration variables highly associated with intake. Then, based on Carpinelli's study, we selected candidate models based on the similarity between actual intake and the estimated intake with accelerometers. For the validation group, we estimate dry matter intake from accelerometer models to create the dry matter intake ACEL variable. Finally, we evaluated the variation in dry matter intake around Calvin in the dry matter intake estimated with the accelerometers. For the statistical analysis, we used the proc-reg of SAS to the calibration group. Then we generate an intercept and a slope that then was used in the validation group. The proc mix of SAS was used to compare the actual dry matter intake and the dry matter intake based on accelerations. Statistical significance was declared at p-values lower than 0.05 and tendency at p-value lower than 0.1. Beginning with results and discussions, for the calibration group, we analyzed the acceleration variables highly associated with dry matter intake. Besides the accelerations on the three axes of each accelerometer, we created new variables based on the difference in acceleration between two consecutive time points. These variables are very useful in estimating intake because, as we can see in this picture, when a cow goes from this position to this position, this movement is commonly observed when they are eating. Following the analysis of acceleration variables, we created different acceleration models. We selected three potential models. Models number 1 and 2 had the greatest correlation between actual and estimated dry matter intake, while model number 3 had the greatest interaction between dry matter intake and time. In this table, we have the comparison between actual and estimated dry matter intake according to the different models. We are able to observe a high similarity between actual and estimated intake in all the models. However, model number 3 presented a higher type day interaction. Here we have the graphs comparing the actual and the estimated intake using models number 1 and model number 2. We can observe that both models were not particularly good in following the variation in dry matter intake in the days close to calving. Model number 3, on the other hand, tended to follow the variation in intake around calving, as we are able to see in this graph. In conclusions, from the acceleration models proposed, model number 3 best assessed the dry matter intake variation around calving. Determination of dry matter intake and the peripartum with sensor methods is of great challenge. We aim to increase the correlation and the similarity of the estimated and the actual dry matter intake. Moreover, we can conclude there is a great potential of using sensor-based methods to estimate dry matter intake around calving, which could help us in the future to flag cows at risk to develop a postpartum disease. Finally, I'd like to thank the South Dakota State University and my lab team for the incredible help. Thank you all for your attention, and I'll be glad to be answering your questions.